There is a metal you have never heard of. It has no color, no smell, and it melts in the palm of your hand at just 30 degrees Celsius, barely above room temperature. It is also inside the radar of every F-35 fighter jet, inside every 5G base station on the planet, inside the night vision systems, the guided missile seekers, and the satellite communications that modern militaries depend on entirely. Its name is gallium. And as of right now, one country produces 99% of the world's supply. That country is China. In December 2024, Beijing turned off the tap, banning gallium exports to the United States entirely. In November 2025, after a Trump-Xi meeting, the ban was suspended. But here is the critical detail almost nobody is covering. The suspension expires on November 27, 2026, and the underlying control architecture, the licensing system, the military end-use ban, the ability to flip the switch again, was never dismantled. Today, we are going to understand what gallium actually is, why China's control over it is one of the most powerful strategic weapons in the world right now, and what happens when that suspension expires. When most people think about the U.S. China military competition, they think about aircraft carriers, hypersonic missiles, cyber attacks, and Taiwan. But here is the question that keeps defense analysts awake at night. What if China doesn't need to fire a single shot to cripple U.S. military readiness? Because right now, the United States cannot build the next generation of its own fighter jet radars without Chinese gallium. It cannot upgrade its Navy destroyers. It cannot manufacture the GaN chips that make the F-35's APG-85 radar, the system designed to detect stealth aircraft, without raw material that Beijing controls entirely. The U.S. Geological Survey estimated that a full gallium export ban alone could cost the U.S. economy $3.4 billion, with nearly half of that impact concentrated in the semiconductor industry. And that is before accounting for the cascading defense procurement delays. China's dominance over gallium is not an accident. It is the result of deliberate state policy stretching back to the 1980s. Beijing backed early investment in gallium recovery, subsidized refining capacity, and systematically undercut global competitors on price until no one else could afford to stay in the business. Here is the structural trap. Gallium is not mined directly. It is a byproduct of processing bauxite, the ore used to make aluminum. The United States still smelts aluminum and refines zinc, but it no longer operates the upstream alumina processing systems where gallium recovery happens. The U.S. cannot quickly build an alternative supply chain because it has already lost the industrial base required to produce gallium as a byproduct. It is not just a question of money. It is a question of industrial capacity that takes a decade or more to rebuild. To understand where we are, you need to see the sequence clearly. October 2022, U.S. imposes restrictions on advanced semiconductor exports to China, blocking chip equipment, cutting off Huawei. August 2023, China responds. First licensing requirements on gallium and germanium exports, a warning shot. December 2024, U.S. expands chip restrictions, adds 140 Chinese semiconductor firms to Entity List. Beijing responds within 24 hours. Total export ban on gallium, germanium, and antimony, specifically targeting the U.S., the first time China has targeted a single country with critical mineral restrictions. November 2025, Trump-Xi meeting. Ban suspended until November 27, 2026. But military end-use ban stays active. Licensing requirement stays active. The architecture of control was never removed. November 2026. Suspension expires. Beijing can flip the switch again with 24 hours notice.
Gallium is not just a chip material. In its compound forms, gallium nitride, GaN, and gallium arsenide, GaAs, it is the semiconductor of choice for the next generation of military radar and electronic warfare systems. The F-35's radar is being upgraded to Northrop Grumman's APG-85, a GaN-based active electronically scanned array system. In 2022, the DoD awarded Raytheon a $3.2 billion contract to equip 31 U.S. Navy vessels with GaN-powered radar systems, including the new Arleigh Burke-class destroyers and aircraft carriers. Every one of those systems requires gallium that China currently controls. Meanwhile, China itself is using its privileged access to gallium to develop next-generation radar technology. In early 2026, Chinese researchers produced 4-inch gallium oxide wafers, a next step toward even more advanced military radar systems. While the U.S. was debating supply chains, China was racing ahead on the technology built on top of those supply chains.
In 1941, the United States cut off oil exports to Japan. At the time, Japan imported 80% of its oil from the U.S. The embargo did not immediately stop Japan's military. It had stockpiles. But it created an inescapable strategic logic. Japan either had to find a new source of oil in Southeast Asia, or its military machine would grind to a halt within 2 years. The attack on Pearl Harbor was not, at its core, an act of aggression. It was a strategic response to resource denial. Japan calculated that a knockout blow to the U.S. Pacific Fleet would buy enough time to seize Dutch and British oil fields in Southeast Asia before American power could be reconstituted. The parallel is uncomfortable, but precise. When a great power discovers that a rival controls a critical material its military depends on, and that the rival is willing to use that control as leverage, the strategic options narrow rapidly. You either find an alternative, you pay whatever price the controlling power demands, or you contemplate actions that seemed unthinkable before the dependency became visible. The U.S. is not Japan in 1941. It has more options, more time, and a larger industrial base. But the structural logic, dependency as strategic vulnerability, and the coercive leverage that dependency creates is the same logic that drove some of the 20th century's most dangerous escalations. Most people think the chip war is an abstract competition between governments and tech companies. Here is why it is not abstract at all. Your smartphone. Gallium arsenide chips power the radio frequency circuits in every mobile phone. The 5G signal that connects your device travels through GaAs RF integrated circuits. Each 5G base station contains 8 to 12 of them. There are approximately 2.3 million 5G base stations deployed globally as of 2025. All of them depend, at some point in their supply chain, on Chinese gallium. Your car. Gallium nitride power semiconductors are now in 30 to 40% of new electric vehicle platforms, including Tesla, Volkswagen, BMW, and General Motors. When China banned gallium exports, the price surged over 200%. That cost does not disappear. It moves through the supply chain and eventually reaches the sticker price. Your taxes and national defense. Every year that the U.S. cannot produce gallium domestically at scale is another year that the Pentagon must pay premium prices for military hardware, delay procurement timelines, or accept strategic risk in its most advanced weapon systems. The DoD's $3.2 billion radar contract for the Navy runs directly through this supply chain. Defense costs are taxpayer costs. The investment thesis. The companies racing to build alternative gallium supply chains in Texas, in Kazakhstan, in Canada represent one of the most strategically important investment categories of the next decade. Not because gallium is glamorous, but because governments around the world have now officially classified it as a national security asset. State support, price floors, and procurement guarantees will follow.